So for our physics project, we went to Santa Rosa Skate Park and decided to do an experiment on the half pipe. And on this particular half pipe, we have one side being much lower than the back side of the half pipe. Good? Good?
Yeah.
So we notice that when I go from the side I drop in on up to the back wall, I have a greater change in the height that I started with. So I start from a height of about 1.75 meters and gain an additional 1.5 meters on the back wall, coming to a total height of 3.25 meters. So at this point is where all my potential energy from point 1, we'll call it potential energy initial, all this potential energy goes to kinetic energy, which we know is mgh is equal to 1/2 mv squared. So from this height of 1.75 meters, by the way, mass cancels because it's in both sides of the equation. From this height, 1.75 meters times the acceleration of gravity, 10 meters per second squared, is going to be equal to 1/2 of the initial velocity at this point, squared. So solving for that, we get V initial is equal to 6 meters per second, considering that this is the positive x direction. But if I end up at a higher point on this side, something must have happened. Skateboarders use a technique called pumping to pump themselves into the transition to gain energy. And therefore velocity. So we can calculate my potential energy at this point and see that my velocity back at the same point, my V final, is going to be greater. So this point is going to yield potential energy, let's call it potential energy 2, and potential energy 2 is going to be equal to the kinetic energy at this point. So kinetic energy, let's call it kinetic energy final. So we know, once again, mgh is going to be equal to 1/2 mv final squared. And again, masses cancel, and we end up with this total height of 3.25 meters times the acceleration of gravity, 10 meters per second, squared is going to be equal to 1/2 of our V final squared, yielding a final velocity of 8 meters per second, but in the negative x direction.
Continuing with the energy lens, we can find out the work Austin does from pumping. We know that work is equal to kinetic energy final minus kinetic energy initial. And we know that kinetic energy is equal to 1/2 mv squared. So we're going to use our final and initial velocities. We know that Austin weighs 80 kilograms, so we can put these values into our equation. We know that our initial kinetic energy is equal to 1440 joules, and our final is equal to 2560. So we know that our work is equal to 1,120 joules. Got it. Switching to the kinematics lens, we can calculate our acceleration. We know that from the bottom to the top to the bottom again, our change in time was 2 seconds. We also know that acceleration is our time derivative of velocity. So we know that acceleration is equal to our final velocity minus our initial velocity over our change in time. We know that our final velocity is -8 meters per second, and our initial velocity is 6 meters per second, and our change in time is 2 seconds. So doing this calculation, we find that our acceleration is equal to -7 meters per second squared.